The diagonal of a rectangle is 20 meters and its length is 16 meters. That's the length of the rectangle, by the way. The diagonal is already 20. What is the perimeter and area of the rectangle? So once again, the diagonal of a rectangle is 20 meters. The rectangle length is 16 meters. What is the perimeter and area of our rectangle? All right, let's see what we're going to do there. First of all, got to have a rectangle. Always helps, doesn't it? We have draw that rectangle again. 4 right angles working for us. And we're going to create one more piece of information here. We got a diagonal involved here, all right? So diagonal, folks, basically goes corner to corner. Let's draw that in. Right, here we go, here we go. Oh, yeah, I know we can get this to draw. Come on, little ruler, do what you're supposed to do. And I'll try to do what I'm supposed to do. There we go, perfect. 20 meters, that's the length right there. Now, this other thing, this length, this rectangle length is, we're going to put it right here on this one. Now you say, Ernie, could we put it at the top? Sure, we could. I'm just running out of space up there. Drew my rectangle a little bit tight there, all right? So what we're looking for is how to find perimeter, how to find the area of this lovely rectangle, all right? So, looking for, as I said, 2 things. You know what would help us? Would help us if we knew this little piece right over here, all right, this little piece of segment length, because that becomes the width, there becomes the length. We need to know what the measurement is. How many meters? How many meters? Well, you say, what are we going to do, Ernie? I tell you what we're going to do. We're going to resort to our good old friend, the Pythagorean Theorem. Nice application of good old a squared plus b squared equals c squared. You say, wait a minute, when do we do the Pythagorean Theorem? What's that about? It's about a right triangle, and notice what happened when we drew the diagonal. You've got a right triangle. It's pretty as you please right there. We don't know what it is right here, but we'll call it W, okay, because it's going to be the width. And once we get that width, we can do all sorts of great things over here in this space, all right? So let's play it out here. Let's go with the first part here, right? As we use the Pythagorean Theorem, if y'all drop my lower third there, it'll help me out some. We've got W squared, because we don't know what it is, all right, plus this 16 squared. Good stuff, all equaling to 20 squared. And you say, where'd you get that, Ernie? Length, or leg in this case, leg squared plus leg squared equals hypotenuse squared. You see, that diagonal has become the hypotenuse of this right triangle right here, okay? So we're going to go with a squared, b squared, and c squared. Hypotenuse is always c. In this case, it's 20. I'll put a little parenthesis around it also so it doesn't freak some of you out. Okay, there you go. And we've got w squared hanging on for good life. Now, everybody got that at home, all right? Got yourself going. Perfect squares. Oh, my goodness, that's what we've got to look for here. Hopefully, we got another one over here for w, but certainly, we can square 16 and we can square 20, because that's our next order of business. So I've got w squared. I have 16 squared, which will be 256. And over here, 20 times 20, you can do that in your head. That'll be 400. Now, let me tell you something here. It's nice to know those perfect squares, at least from 1 squared up to 20 squared, just to be able to kick them off. Basically, you already know 1 through 12 by knowing your times tables, all right? And 20 times 20 is not very hard, so really all you got to learn is 16, 17, 18, 19, and some of you already have 13, 14, and 15, but that's only 7 other numbers, all right? So 13 all the way up to 19 perfect squares. Nice to know them. That just popped off the top of my head because I used it a lot. And by the way, you use a lot of these things in your geometry, your trig, your algebra 2, all those good classes, and of course calculus. It's nice to know those. It's nice to recognize those perfect squares because they lead you on down the road to some things called triples. Let's see if we got one of those, by the way. We're going to subtract our 256. Right there we go. Subtract it off because we want to have w by itself. And it looks like I'm about to run out of room. So how about it? Let's say w squared. Pull it right up to here. W squared is going to equal to 144. That's what happens when we subtract 256, good old subtraction property of equality from both sides. Now it's time to play the square root game, all right? So we're going to square root 144 because we need to get back to w, all right? So let's take a square root of w squared, and we're going to also do that for 144. As I said, know those perfect squares, you know, because 144 is a perfect square. 12 times 12. So here we go. W equals 12. They say, Ernie, we're going to use positive or the negative. We're going to go positive. Why? Because it's a length or a width here. It's a measurement, all right? It's called the length of a side, width of a side, width of the rectangle. Boy, all those W's and L's, don't let them get you confused. We're finding the measurement of this line segment right here, okay? And that is 12 meters. Now you say, where's that going to help us? Oh, it's going to help us a lot. Because you know why? I'm going to draw more boxes here. That's lovely. Now, let's do it. Let's find the perimeter first. What is the perimeter of this creature here? It's a rectangle. So it's going to be 2 lengths, which we already know there's 16, plus 2 widths. Well, we figured that out now. It's 12. That equals the perimeter. All right, that's your perimeter. We didn't give you the perimeter, but we're going to find it very easily here. All right. So 2 times 16 gives us 32. Add another great moment here. How about it? We're going to have 24. And by the way, these are all meters. So piece them together. Piece them together. It looks like we have 56 meters for our perimeter. Quick check. I always like to do that. Let's say if we put a 12 right over here, if you were to add all 4 sides together, well, 12 and 16 do give us 28. And 28 more gives us 56. So there's more ways to get to that 56, but you got to some way get a perimeter added up. Now, remember there's a second part to this. Find the area. So let's do an area real quick. How about it? Area equals length times width, or width times length. Commutative property, either way we go there. And let's put some numbers in there. So we're going to put in 12 times 16. Sometimes we use base altitude. Sometimes you'll hear, all sorts of different things, expressions. Basically, it boils down to multiplying these two line segment lengths together to get an area. By the way, what is 12 times 16? Believe it's going to be 192. Let's check it out on the calculator and see if I hit this one right. Sometimes I hit it, sometimes I don't. We try our best. Let's see, I believe we got it this time though. And enter. 192 it is, 192. By the way, that's not meters. That is square meters. All right, or meters squared as we like to say. So there you go.
For more math help, visit TNLearn.org.